In this section, we will be dealing with simplifying square roots. So when you have the square root of 25, that is 5. When you have something like the square root of 20, well, you can use a calculator to figure this out and get a decimal form of it, and it's like 4 point some stuff after it. Sometimes you need to leave them as an exact value, and so we have to have a way to simplify them. To do that, you factor it. And you can factor it in any way you want. So one way that you can do that is to say 2 times 10. Now you look at the numbers that you just factored, and can you take the square root of either one of those two numbers? Well, there is no square root for 2, and there isn't a square root for 10 either. So then we try to factor even more. And that turns into 2 times 5. Well, there is no square root for 5, and there's no square root for 2, but we have a 2 here, and we have a 2 there, and so there's a pair of 2's, and 2 times 2 is 4, and the square root of 4 is 2. So then this can turn into 2 times the square root of 5. And what that means is, or when you're doing this factoring, anytime you have a pair of something, because this is square root, and there's a 2 there, but you don't have to write it, anytime there's a pair of numbers, you can take those numbers and they get to leave from the square root as that number. If there's a number out here or you're bringing more numbers out to it, then you multiply those things together. Anything that doesn't have a square root or a pair, then you have to leave it underneath. Now the other way that you can do the square root of 20 is say, well, hey, that's 4 times 5, and then I know that the square root of 4 is 2. And you're still at 2 times the square root of 5. Either way, it is fine. So the rules for a square root, if you're trying to find it and simplify it to an exact value, is you can have nothing under the radical sign can have a square factor other than 1. Which means like this, you have to break it down, and then you've got this. Well, the only factors for 5 are 1 and 5. Well, that's a square factor because the square root of 1 is 1, but that's the only thing that you can break that down to. The other rules for square roots is you can have no fraction under a radical sign, and there's no radical sign can be in the denominator. And finally, the last rule is you cannot have a negative under the radical sign. And we will go through all kinds of different examples to look at those things. This is a radical sign. And it's square roots. Later on in this class, we'll get into things where that could be a 3, 4, a 5, and then that's third root, fourth root, fifth root. But for now, it's just square root. So here we have the square root of 80. Well, you can start out and say it's 2 times 40, and then that's 2 times 20, and then you have a pair of 2's that get to leave as a 2, and then 20 can be 4 times 5, and then the square root of 4 is also 2, and so 2 times 2 is 4, and then the square root of 5. Now if you have the square root of 80, you could have started out and said, well, let's see, that's 10 times 8. And then that's 5 times 2, and that's 2 times 4, and here's a pair of 2's that leaves a 2, and the square root of 4 is a 2, and you're still at 4 square root of 5. Or you could say the square root of 80 is the same as 5 times 16, and then, oh, hey, the square root of 16 is 4. And you're still at 4 square root of 5. I'm just showing you that there really isn't a wrong way to go about it. Sometimes it's shorter, like if you know what things are perfect squares, like 5 times square root of 16. Or sometimes you can do it this way where you break it 8 times 10 or 2 times 40. Any of them will work. It's just what you prefer to do. So looking at our next example, 720. Well, let's see, that's 72 times 10, And 72 could be, let's see, 8 times 9. And then that's 2 times 5. And then 9, the square root of 9 is 3. And then 8 can be 4 times 2. And then we have the square root of 4, which is 2. And then there's a pair of 2's that can come out also. That's another 2. So now we have 2 times 2 times 3, which is 12. And then there's only a 5 left over, so it's 12 times the square root of 5. Now another way you could have broken that down is said 5 times 144. And then the square root of 144 is 12. Or there's many other ways to go about that. 2 times 360, and then 36 and 10. And then 10 can become 2 and 5, and the square root of 36 is 6, and then a pair of 2's is 2, so then you get to there. However you want to go about that. All right, so now when you have a fraction, you can't have a fraction underneath the square root, but now is there a square root for 3? No, so then we leave it as square root of 3. Is there a square root for 16? Yes, it's 4. Hey, we don't have a fraction underneath the square root, and there's no square root in the denominator, so there's our answer. It's simplified. Looking at this one here, is there a square root for 10? No, so we'll leave it as square root of 10. Is there a square root for 3? No, so it's square root of 3. Well, now we don't have a fraction underneath the square root, but we do have a square root in the denominator. So we have to get rid of that. And there's a couple things you can do to a number that doesn't change a number. Say you have an 8. Well, there's a math operation that is going to get you 8 for an answer. One is to add 0. Well, adding 0 does nothing. But you can also take 8 and multiply it by 1. I suppose you could subtract 0 too, but we're going to multiply by 1. And 8 times 1 is 8. Well, 1 is a special number because 1 can take on many different forms, like 2 over 2, 8 over 8, 76 over 76, a over a, square root of 5 over the square root of 5, square root of 3 over the square root of 3. Anything like that is 1. It doesn't change our number if we multiply by 1. So in this instance here, because there's a 3 in the denominator, square root of 3 in the denominator, we have to multiply by a form of 1. That form of 1 is the square root of 3 over the square root of 3. In the numerator, square root of 10 times the square root of 3, well, you just multiply these two things together, which is 30. Now, if you try to break 30 down, that's 5 and 6 and 2 and 3, and you can't take the square root of any of those, and there's no pair, so square root of 30 it is. The denominator, well, if you take the square root of 3 times the square root of 3, hey, you have a pair of 3's. They get to leave as a 3. So you have the square root of 30 over 3 is the final answer. All right, here we have the square root of 5/18. So we would start by saying square root of 5 over the square root of 18. Now, you can simplify some of this first, or you can try to multiply by the square root of 18 over the square root of 18 first. Doesn't matter to me, or I mean, it doesn't matter when you do this. For me, I'm going to first simplify this because that's the same as 9 times 2. And the square root of 9 is 3. So I'd have 3 square root of 2 in the denominator and the square root of 5 in the numerator. Now we still can't have the square root of 2 in the denominator. We can keep the 3, but not this. So we have to multiply by a form of 1, which is the square root of 2 and the square root of 2. Square root of 5 times square root of 2 is the square root of 10. And square root of 2 times the square root of 2, that's going to be just plain old 2. And 3 times 2 is 6. And there's your answer, square root of 10 over square or 6. Now, the other way that you can do this is not simplify it first and then multiply by the square root of 18 over the square root of 18. Well, the denominator then turns into 18, and this becomes square root of 5 times 18, which is, 9, no, 5 times 4 is, 5 times 8 is 40, so 90. And then that breaks down to 9 and 10, and the square root of 9 is 3 times the square root of 10 over 18. And then because you have a 3 and an 18, you can divide those two things, so that becomes square root of 10 over 6. Same thing, just a different route. All right, let's look at this one. Here we have 3 times the square root of 10 over 18. Hey, that's that right there. So now before we do this, well, it's similar to that one, but because these two things are underneath the square root, you can simplify 10 and 18 because 2 goes into both of those things. So you have 3 square root of 10 over square root of 9. And now the square root of 9 is the same as 3, and 3 square root of 10. And then you have a 3 in the numerator and a 3 in the denominator, which can divide out, and you're left with the square root of 10. Same with this one. Square root of 80 over the square root of 4. Well, because they're both underneath the square root, 80 divided by 4 is 20. So you have the square root of 20. And then that can break down to 4 and 5, and the square root of 4 is 2. And the square root of 5 you just have to leave. Now then, square root of 16 is 4, square root of 9 is 3, square root of 4 is 2, square root of 1 is 1, the square root of 0 is 0, and then the square root of a negative 1 is I, which stands for an imaginary number. And I is equal to the square root of negative 1. So then, a square root of a negative 4 is 2i, because the square root of 4 is 2, and then because you have the square root, that's like a negative 1 times 4, and the square root of 4 is 2, and the square root of a negative 1 is I. So then the square root of a negative 9 is 3i, and the square root of a negative 81 is 9i. And if you're going to simplify the square root of a negative 28, well, that's like 4 times 7, and the square root of 4 is 2, square root of 7, and then because it's negative, put an I at the end of it. Now you can write it that way, or you can go 2i square root of 7, but usually people write it this way. Just make sure that when you write it, you do not do that, because you're not taking the square root of I. It can't be over that. So it's 2 square root of 7i. One final thing. Otherwise, simplifying something like this is no different than if it was a positive number. You just have to stick an I at the end. Now with something like this, you have to simplify before you multiply. So this is 2 and 4. So 2 square root of 2i. And then that would be times the square root of 6i. And then this times this is 12. And then I times I is I squared. And 12 can be 4 times 3, so the square root of 4 is 2, so 4 square root of 3I squared. Now we know that I is equal to the square root of a negative 1, while I squared, if you take and square this and you square that, is equal to a negative 1. So then this turns into a negative 1, and a negative 1 times 4 square root of 3 would be a negative 4 square root of 3. So here we would have the square root of 2 over 3i, because the square root of 2 stays and the square root of 9 is 3. This one here is like the square root of 3 over the square root of 5i times the square root of 3 over the square root of 10i. And so then, let's see, square root of 3 times square root of 3 is 3. I times I is I squared. That's like 2 times 5, and you have a pair of 5, so 5 square root of 2, I squared. So then that can be changed to 3, 5 square root of 2, and a negative because I squared is a negative 1. Well, then we got this crappy square root of 2 in the denominator, so we have to multiply by the form of 1, which is square root of 2 over square root of 2. So you're going to get 3 square root of 2 over 5 times 2, which is 10, and it's going to be a negative. And that is how you simplify square roots.